Physical Science, we're back. Chapter 25, Section 4, Part 2, Eruptive Products. Magma erupts from a volcano or fissures onto Earth's surface as lava or ash. So what we call underneath the surface, magma, it's still the same material above the surface, but if we're talking about magma above the surface, we can't call it magma anymore. We call it lava. Viscosity is a measure of a fluid's resistance to flow. Learn that sentence, not going away. And so in this case, we're talking about the viscosity of lava. Lavas can vary considerably in composition, which in turn affects their physical properties, like viscosity. Silica is the chemical compound silicon dioxide, otherwise known as SiO2, which is the common ingredient in magma. Magmas with high viscosities contain more silica. Magmas with high water content have low viscosities. So if we were to look at this and put it into a real world situation, something that's highly viscous means it's thick, it's slower running, not going to catch up to you pretty quickly, especially in the case of lava. It's something more like honey, whereas something that is low in viscosity or less viscous, it's runnier, more like water or a really fast running syrup. Another type of eruptive product is pyroclastic material. Any solid material that erupts from a volcano is classified as pyroclastic material. For example, volcanic ash is the smallest pyroclastic material. Volcanic blocks and bombs are the largest pyroclast material. Another eruptive product, gases. Volcanoes erupt a variety of gases including water vapor, carbon dioxide, and sulfur dioxide. Sulfur dioxide can mix with water and reduce the amount of solar radiation reaching Earth. So nothing is ever simple. Not only do we have plates, but we have 3 different kinds of plates. And for each plate, it depends on if it's in the ocean or if it's on the continent, depending on what we call it and how it functions. Well, guess what? There's different types of eruptive styles, and there's different types of shapes of volcanoes. So let's start with eruptive styles. Volcanoes can erupt in a variety of ways depending on its magma composition and velocity. Eruptive style is strongly linked to both temperature and composition. And remember, temperature and composition, it affects the viscosity of a liquid. Think about honey, room temperature, versus honey that's 100 degrees. One's going to run much faster. So volcanoes are also classified according to their size, shape, and the materials they erupt. The first one, a cinder cone. It tends to be small, have heights in the hundreds of meters range, and have short eruption cycles. They also erupt high-temperature, gas-rich basaltic lava.
Cinder cones consist of pyroclastic material that has settled out in a cone near a volcanic vent. A cinder cone is built as pyroclasts are ejected into the atmosphere and rain down around the volcanic vent. The larger, heavier pyroclasts settle close to the vent, and the smaller, lighter material settles farther away. Lava flows are also associated with cinder cones. The lava is too heavy to flow over the top of the growing cinder cone. Instead, it flows beneath it, pushing the pyroclasts out of the way. The pyroclasts accumulate around the vent and settle at the angle of repose, forming a cinder cone. Much of the original lava flow is buried by the pyroclasts.
And here's a few short examples of what cinder cones look like. This one in particular I like. And the reason why I like it is because you can see the shading and how it changes and how that ash continues to build up over time. That's a really good indication it's a cinder cone. Shield volcanoes are broad, flat structures composed of layer upon layer of lava flows. Shield volcanoes form from high temperature, low viscosity basaltic lavas. Now, if you have not made yourself learn viscosity and what it is to be low or high viscosity, you are not going to do very well on the test. And here's why. It's centralized around everything. And viscosity is going to follow us probably the rest of the year.
Residents are being evacuated after a volcano on one of Vanuatu's northern islands began to erupt. The Manaro volcano in Ambae is a shield volcano whose summit features 3 crater lakes. The volcano began releasing ash and toxic gas in September and is now spewing rocks and lava amid repeated explosions. Many of the island's water sources are polluted by the eruption, leaving thousands without access to safe drinking water. Islanders are being ferried off.
Building a shield volcano looks something like this. It was hard to find a short little clip video, so we're going to use this. As you can see, it's broader than it is tall. Now, that doesn't mean that shield volcanoes can't get super, super high, because clearly the Hawaiian Islands are pretty big. However, the circumference will always be larger than the height in the original formation of a shield volcano. And the last type, composite volcanoes. These are formed from alternating explosive events that produce pyroclastic materials and lava flows that are called composite. And here's a few examples. So for the last video clip, we're going to be viewing the composite volcano being built. And I'm just going to watch it first and then go back and explain. Okay, so hopefully you've noticed that there is an AB pattern. Remember that? AB pattern goes back and forth. Here we have mostly ash. Here we have mostly lava. Here we have mostly ash. Here we have mostly lava. And the eruptions happen throughout. And it causes the barriers to be different. You can see thin layers of ash followed by large amounts of lava. It can go either way. The point is, it's composite. It's a composite between one type of an eruption and a completely opposite type of eruption that just so happens to occur inside the same volcano. So of course, these only happens in certain areas of the world because you need to have all the right compositions, silica content, viscosity, water, salts, different types of rocks. You need to have all of that in a great combination in order to come up with a composite volcano.